Okay, so you might remember starting in quadrant 1, hopefully you have those down. Tangent of 0 is 0, pi over 6 is square root 3 over 3, tangent pi over 4 is 1, tangent pi over 3 is square root 3, and tangent pi over 2, undefined, because you end up having to divide by 0 in your coordinates, y over x. And so then I just went around my unit circle and I did the other tangents. So like in quadrant 2, they're negative. In quadrant 3, they're back to positives. And in quadrant 4, they're negatives again. But what I'm going to do with that is I'm going to graph it. And I don't know that you necessarily have to graph this part because we're going to get a blue sheet similar to our sines and cosines. So I think just following along with what we're doing on the board so that you can see why tangent looks the way it does would be really helpful. So I'm going to move this down a little bit, and I'm going to create like a coordinate plane. And we are going to end up putting tangent into a frame. But on my coordinate plane, I'm going to go ahead and say, like maybe that's 0.5. So this is 1, there's 1.5. Here's negative 0.5, here's negative 1, here's negative 1.5. Kind of similar to what we had for our sine and cosine parent graph. And then I'm going to put in over here, I'm going to just do 4 for the quadrantals. So there's pi halves, pi, 3 pi halves, and 2 pi over here. Because that's the radians or the angles around the unit circle. Okay, so next up I'm going to go and I'm just going to start at 0. And I'm going to start like filling in and plotting points for where they are. And again, I don't think you necessarily have to do all this. It's just you're going to see why tangent looks the way it does. So starting at 0, angle 0, the tangent of 0 is 0. So we get a point at the origin, 0, 0. As we move up to pi 6, we get square root 3 over 3. Square root 3 is like 1.73. If you divide that by 3, it's going to be a little less than 0.6. So it's like a little bit more than 0.5. When you do the square root of pi over, or sorry, not the square root, the tangent of pi over 4, you'll get 1. So right in the middle of 0 and pi halves is pi fourths, and I'm at 1. And then when I do the tangent of pi thirds, I'll get square root 3, which square root 3 is that 1.73. So that's just before I get to pi halves. I'm at like 1.73, so I'm a little bit up there. And then interestingly, when I get to pi halves right here, I get something that's undefined. So I would skip over that, and I don't have a point to plot anywhere at pi halves. It's undefined. There is no y value. Okay. When I move over into quadrant 2, then all my tangents are symmetric, but negatives, right? So when I get to 2 pi thirds, the next angle, I'm going down 1.73, so that's somewhere down here. Negative 1 for 3 pi fourths. This would be like negative 0.6 for 5 pi 6. And then when I get to pi, I'm back to 0. And then I start going up. So then I get 7 pi 6 is that 0.6 value. 5 pi fourths is 1. And 4 pi thirds is 1.73. So you can kind of see like that's the repeat, right? And then again, I hit that quadrantal angle at the negative y-axis. The tangent of 3 pi halves does not exist. It's undefined. So I don't have a point to plot. And I would skip ahead over here to quadrant 4, where they go back to being negative. So I'm at like that negative pi, negative 1.73, negative 1, negative 0.6. And then at 2 pi, I'd be back to 0. So you can kind of sort of get the gist here of like that you just kind of keep going from the negatives to the positives. And so if I try to connect the dots here, what I'm going to have is something like this, where you guys might describe that it looks like a cubic graph, sort of that like weird bend shape to it. You can sort of fill in with your brain, right? What would happen if I went on this side? It's the part that goes down, and then it would just repeat on the other side. So the big difference, it's not actually like a cubic graph repeated, because a cubic graph would have a domain of all real numbers. It extends in all directions, left and right, forever, without any issue. But tangent keeps having these like hiccups where we can't plot anything, and what you actually have right there are vertical asymptotes. So this like bendy graph is trapped inside of the vertical asymptotes. And that's what's behind the screen over here. I'm gonna move that. It's that image, like I did it for sine and cosine. I just Googled and I found like a little animation here where it's going around the unit circle. This time it's picking up the blue and the red, which is adjacent and opposite, and it's doing the tangent values as it goes around. But probably the big takeaway for you guys here before I hand you the blue sheet is if you looked at this tangent graph, and you know a period is how long it takes the graph to start repeating itself, what is the period of the parent graph of tangent? It's just pi, right? So like you might be looking from this pi halves to 3 pi halves. There's one branch of tangent. That's 1 pi. And then, sorry, this one would go over more. This would be 5 pi halves. I should have had my asymptote further out. But 5 pi halves minus 3 pi halves is 1 pi. And then this asymptote over here must be at negative pi halves. So if we're talking about the parent graphs y equals tangent x, one important thing to note is that your period is smaller than it is for sine or cosine. So that's going to affect how we calculate periods for all tangent graphs. Instead of doing 2 pi over b, now we'll do pi over b. Because it started smaller. We can still horizontally stretch and shrink it, but it starts smaller. What would you say about amplitude? Half the distance from the min to the max? Don't have one, don't know. There is no min and max, right? So amplitude, not applicable, does not exist. You might say that the A value is 1, and that's true. There is no vertical stretch or shrink compared to the parent graph, but when I ask about amplitude, tangents don't have amplitudes. Only sine and cosine, the waves, have a half distance from min to max. And then the other big takeaway from tangent is obviously there's an issue with domain, right? Because every pi halves unit, or like every pi after pi halves, I come up with an asymptote. So there's like these like breaks in my domain over and over again. I won't ask you about domain for tangent, but I will ask you range. What would you say for range? All real numbers. Negative infinity to infinity. Okay, so that's like the basics about like the general tangent graph. So like hopefully on the quiz that you turned in, you drew waves only. And then going forward into next week, your test is scheduled for Thursday and Friday. That's going to be over chapter 4. And you'll have the other graphs on the test. You might draw waves, or you might draw these tangent branches. You'll have to decide what the correct picture is. So I think the pods, some of the pods have tape already. So if you just want to grab like 2 pieces, you need one for the top, one for the bottom. Grab 2 pieces, send it around your pod, and then give it to another pod. So Kylie, I'll have you guys pass yours up to Andre. Brody, if you'll send yours over to Austin's group. And Margaret, if you'll pass your groups up to Katie, then we'll get all the pods to have tape. Okay, so as people are getting the tapes and putting it in the notes if they choose to, I'm going to talk about the stuff that's on the blue sheet. You got a new blue sheet because we're doing the frame for tangent a little bit different, so it's important to pay attention, and I'll try to highlight what's different. First of all, I didn't write it in the notes, but if you want to put a box around it so you notice it, the equation for tangent is really the same. Even though we would say tangent doesn't have an amplitude, it does have an A value. Those things still do the same stuff. Vertical stretch or shrink, horizontal stretch or shrink, horizontal shifting, and up and down vertical shifts. Notice that the starting point, the way that you would get the starting point is the same. It's C over B, comma D. But you might want to make note that it's in the center of the frame, so it's actually in the middle, it's not on the side. So the construction of the frame is going to be different. I think they already have it. Any other groups need tape? This one right up here, sorry. So you can see that down below, like I've marked the starting point. Instead of being over on the side of the frame, it's like right in the middle. Okay. And the reason for that, okay, I'm going to switch just really quickly. The reason for that is if I don't shift the viewpoint of the frame, then we would always be graphing with an asymptote in the middle. And we would have part of tangent on the left and part of tangent on the right, but we'd never see the whole curve. So we're just saying instead of looking right there, let's just shift it so our asymptotes will be on the side of the window of the frame, and then we'll get to see the whole curve in the middle. Okay, so that's why we're putting the starting point in the middle now. Notice in 2, I'm not calling it amplitude, but it is vertical spacing, so you still build the frame the same way with A. So if you notice it's 1, you would just add 1 and subtract 1 from your D value of your starting point. Okay, and then star, circle, highlight, period is different for tangent. Okay, periods only take pi units to repeat for their parent graph, so we're going to do pi over b instead of 2 pi over b. So that's different than sine and cosine. Because the starting point has been moved to the center of our frame, there is some slight change to the directions for how you label the horizontal part of your frame. So method 1, you can add or subtract half the period on the right and the left and then split it in half again. Okay, so before we would just add the full period to the right and then split it in half and split it in half. Okay. But now we're saying that starting point, we really need to have half the period on one side and half the period on the other. So we'll have to add and subtract. Okay. Or I really like method 2 for a lot of us. You're going to add and subtract a fourth of the period on the right and the left. Okay, so you can still figure out your period, like your horizontal spacing by dividing your period into 4 equal parts. But you need to put 2 parts on the right, so add it, and 2 parts on the left, so subtract it. And that's how you get your label for your frame. And then you'll plot the critical points and the 2 asymptotes, sketch the graph. So let's make sure we get the tangents in here. Tangent with a positive A. We shifted it so the starting point is in the middle because this was the point 0, 0. So if tangent has a positive A, it's increasing from left to right. So here you're going to have a max point on the frame, but it's going to continue, so it's no longer the maximum. Okay, and then you're going to go straight to the minimum. And on the sides, you draw asymptotes. So the asymptotes are on the sides of the frame, and then you get that nice curve in the middle. If you have a tangent with a negative A, then you're reflecting horizontally. So then your graph is decreasing from left to right. You still have asymptotes on the left and the right. The center will still go through the starting point. So cosine is really the only graph so far that doesn't start at the starting point of the frame or go through that point. And then you're going to go from high to low. That's tangent with a negative. Positive tangents increase from left to right. Negative tangents decrease from left to right. Okay, so I'm going to squeeze in one quick graph just so you can kind of see how this is going to play out, and we'll do another one on Monday to refresh our memory. Monday will also include cosecant and secant, which will be going back to like how we created sines and cosines because those are the reciprocal functions. Okay, so I'm going to graph y equals 1/2 tangent of x over 3. I still kind of want to find those three things that I used to find. The big difference with tangent is I'm not going to call it an amplitude. So I'm just going to find A, or like the absolute value of A, I suppose. I'm going to find a period, and I'm going to find the starting point. Because I still need those things for my frame. So my A value is 1/2. So that means from my D of my starting point, I'm going to add a half, subtract a half to build my vertical frame. My period, we have in the notes, is pi over b instead of 2 pi over b. And what's our b value? 1/3, right? It's x divided by 3. So it's like having a 1/3 x. So we're dividing it by a third. If you divide by a third, you're really multiplying by 3. So our period, we have a horizontal stretch. It's stretched out to 3 pi. And our starting point, this one's pretty easy. 0, 0, right? So I draw a frame, 8 panes. Okay, same frame as before. There's just a little tweak to me labeling my sides with my starting point. Because before, it would be the midline on the left side, right? Because the starting point was over here on the left. But now the starting point is right in the middle. So this point right here is 0, 0. Which means this is 0 for y's and 0 for x. Okay, so now like my x coordinate of my starting point is down in the middle instead of on the left. Because my starting point is in the middle of the frame. We okay with that? All right, build it vertically. Add a half and subtract a half from 0. So it's going to go up to a half and down to negative 1/2. And then my period is 3 pi. So if I use method 1, half of that is 1.5 pi or 3/2 pi. So I'll have 3 pi halves on this side, negative 3 pi halves on that side, so that I have 1.5 pi on either side of 0. And then, like I would either need to know like what's in the middle of 1 and 1.5. So between 0 and 1.5 is 0.75, which is 3 pi fourths. And negative 3 pi fourths. Or I could have taken my period and divided it by 4, and then I could have just added 3 pi fourths. Subtracted 3 pi fourths. Okay, so this would have been my spacing. Okay, then I can draw my graph. The left side is an asymptote. The right side is an asymptote. And it's positive, so it's increasing. Something like this. We'll pick up with this on Monday. if you want to try any of the tangent problems, you're welcome to. There's probably only a couple.
Miss Crawford,
Mhm.
why is it 3 pi over 2 and not just 3 pi? Since it starts
Yeah,
at
that's what I was.
0, 0?
Why is what?
Why is it 3 pi over 2 and not just 3 pi since it starts at 0, 0?
Because remember, this window should be one period. And since we put the starting point in the middle, we're putting half the period on the right
Oh.
and half the period on the left. Because this is like negative 1.5 and positive 1.5, and those two have distances of 1.5, so the distance is 3. Yep. Tangent's just a little bit different.